Welcome back to the channel. In most of the stories we tell about the universe, there is an unspoken assumption sitting quietly in the background. It doesn't announce itself. It doesn't demand attention, but it is always there. The assumption is that observation matters, that looking is somehow fundamental, that watching is an active ingredient in reality itself. In this video, I want to slow down and gently set that assumption aside, not to reject it, not to argue against consciousness or diminish human experience, but to ask a simpler, deeper question, one that physics itself forces us to confront. What does the universe do when no one is watching? This is not a trick question, and it is not a philosophical game. It is a physical question, because for most of cosmic history, there were no eyes, no instruments, no minds, no observers of any kind, and yet the universe did not pause. It did not wait. It did not remain undefined, undecided, or incomplete. It proceeded. Stars formed, galaxies assembled, chemistry unfolded, structure accumulated. Complexity grew, slowly, unevenly, and without commentary. All of this happened long before life appeared, and long before anything capable of reflection existed. If observation were required for reality to function, the universe would have stalled almost immediately after it began. And it did not. So this pillar is about removing ourselves from the center of the picture, not emotionally, not morally, but physically. It is about understanding a universe that does not need meaning in order to operate, does not require intention to select outcomes, and does not depend on awareness to leave lasting records. This is not a hostile idea. In fact, it is a humbling one. Because if the universe functions perfectly well without observers, then observation is not the engine of reality. It is a late-stage phenomenon produced by it. We tend to imagine that meaning precedes structure. That purpose comes first, and systems follow. But physics tells a different story. Structure comes first. Persistence comes first. Meaning is something that appears locally, temporarily, when certain arrangements of matter and information become capable of reflecting on themselves. In other words, the universe does not exist for observers. Observers exist because of the universe. That reversal matters. Throughout this video, we are going to explore a universe that operates blindly, not blindly as in randomly, but blindly as in without foresight, without goals, and without concern for interpretation. We will look at how selection occurs without intention, how memory forms without minds, and how physical interaction is often mistaken for observation. We will examine why stars do not need to be seen to burn, why galaxies do not require witnesses to rotate, and why chemistry does not wait for comprehension before it reacts. And then, only after all of that, we will return to observers, to life, to awareness, to intelligence, and ask how something that feels so central could arise so late and occupy such a small slice of cosmic time. This pillar is not about denying meaning, it is about locating it correctly. Meaning is not written into the universe at the start. It is written locally, temporarily, by systems that persist long enough to care. And when those systems disappear, as all systems eventually do, the universe continues, untroubled, carrying forward only what was physically preserved. So as we begin this long walk, I want you to imagine something difficult. A universe with no one asking questions, no one measuring outcomes, no one assigning significance, just matter, energy, geometry, and time doing what they do best, persisting. Section 2, the universe before life. Before there were observers, there was already a universe. This statement sounds obvious at first, almost trivial, but when you sit with it for a moment, it becomes quietly unsettling, because it forces us to imagine a reality that was not incomplete, not undecided, and not provisional, even though nothing was there to notice it. For the overwhelming majority of cosmic history, there were no eyes, no sensors, no memories, and no interpretations. There was no experience occurring anywhere in the universe. And yet, everything that makes experience possible later was already being built. The early universe did not hesitate. In its first moments, space expanded, cooled, and differentiated. Energy redistributed itself according to geometry and constraint. Particles formed, decayed, and interacted. Forces separated into distinct regimes. None of this happened for anything. There was no anticipation of life, no preparation for observation, no latent intention embedded in the laws themselves. The universe did not behave as if it were waiting for validation. It behaved as if existence alone was sufficient. As the universe cooled, it crossed thresholds, not symbolic ones, but physical ones. Temperatures fell below critical values. Interactions that were once unified became distinct. Matter became stable enough to persist. Protons and neutrons assembled. Electrons found places to bind. Atoms formed, not because atoms were meaningful, but because they were allowed. This is one of the most important lessons of early cosmology. Structure does not require meaning. It requires conditions. Hydrogen did not form because it was useful. Helium did not form because it would someday fuel stars. These elements formed because the universe expanded and cooled in a way that made those configurations energetically favorable and dynamically stable. Nothing about this process depended on awareness. No one was there to name hydrogen. No one was there to recognize helium as the second element. No one was there to admire the elegance of simplicity. The universe crossed these thresholds anyway, and it kept crossing them. For hundreds of millions of years, there were no stars. Space was dark, diffuse, and quiet. Not quiet in the sense of absence, but quiet in the sense of patience. Matter slowly accumulated under gravity. Tiny fluctuations in density grew, not because they were important, but because gravity amplifies unevenness wherever it exists. The universe did not smooth itself out. It did not prefer uniformity. It followed gradients. Where there was slightly more matter, gravity pulled slightly harder. Where gravity pulled slightly harder, more matter accumulated. This feedback loop required no awareness, no interpretation, and no purpose. It was not trying to create galaxies. It was simply responding to imbalance. And imbalance persisted. This is a key idea that will echo throughout this pillar. The universe does not optimize for meaning or beauty. It responds to persistence. Structures that can endure under existing constraints continue. Structures that cannot disappear. This filtering happens automatically, relentlessly, and without regard for outcome. Long before life appeared, the universe had already performed countless acts of selection. Regions that collapsed became denser. Regions that expanded became emptier. Energy that could radiate away did so. Configurations that shed excess energy survived longer than those that could not. These were not choices. They were consequences. To call this blind is not to call it random. Blind processes can be highly structured. They can be lawful, predictable, and extraordinarily creative over long time scales. What they lack is intention. What they lack is foresight. What they lack is any concern for interpretation. The universe did not know it was forming stars. It did not know it was laying the groundwork for chemistry. It did not know it was building the preconditions for life. It simply followed the path of least resistance through an evolving landscape of constraints. And that was enough. This challenges a deeply ingrained habit of thought. We are accustomed to interpreting complexity as evidence of planning, coordination, or design. When we see layered structure, long chains of dependency, and intricate interactions, we instinctively imagine a guiding hand or a central narrative. But the early universe offers no such comfort. There is no center, no overseer, no audience. There is only process. Time moves forward, energy redistributes, geometry responds, matter clumps, radiation escapes, entropy increases, not as disorder, but as the spreading of possibilities across larger regions of phase space. All of this unfolds without pause, without commentary, and without reference to meaning. And importantly, none of it needs observers to be real. The universe before life was not a vague probability cloud waiting to be collapsed. It was not suspended in ambiguity. It was not incomplete. It was fully engaged in its own dynamics, leaving behind physical records in the form of structure, distribution, and constraint. Those records still exist. We see them today in the cosmic microwave background, a fossil imprint of conditions from a time when no structure larger than atoms existed. We see them in the large-scale distribution of galaxies, the amplified echoes of primordial density fluctuations. We see them in elemental abundances, the chemical memory of early nuclear processes that occurred billions of years before the first cell formed. None of these records were created for us. They were created because processes leave traces. This is a crucial distinction. The universe does not need to be observed in order to record its own history. Physical interaction itself is sufficient to encode memory into matter, energy, and geometry. When particles scatter, when radiation propagates, when matter collapses or disperses, information is written into the state of the system, regardless of whether anyone is there to read it. The early universe was already a ledger, not a conscious one, not a narrative one, but a physical one, a record written in distributions, correlations, and constraints, durable enough to survive cosmic expansion and accessible billions of years later to creatures who were never anticipated. Life did not awaken a sleeping universe. Life entered a universe that had been busy all along. This realization reframes our place in cosmic history. We are not witnesses to the beginning in the sense of participation. We are archaeologists of processes that did not require us. Our measurements do not complete reality. They decode it. And that decoding is possible only because reality was already complete enough to leave legible traces. So when we talk about a universe before life, we are not talking about a universe that was unfinished or inert. We are talking about a universe that was already structured, already selective, already recording its own evolution, all without the slightest awareness that awareness would someday exist. In the next section, we will look more closely at what this structure looks like when meaning is removed entirely, how order emerges not from purpose, but from constraint, and how the universe builds complexity long before anything is around to appreciate it. Section 3, Structure Forming Without Meaning. When we use the word structure, we almost always smuggle meaning into it. We talk about structure as if it were evidence of planning, as if arrangement implies purpose, or as if order must be aimed at something. In everyday life, that assumption usually holds. Buildings are structured because someone designed them. Languages are structured because minds shape them. Tools are structured because they are meant to do something. But the universe does not share our habits. In physics, structure does not arise because it is useful. It arises because it is stable. This is one of the most important mental shifts required to understand a universe without observers. Stability, not meaning, is the organizing principle. Configurations that can persist under given conditions remain. Configurations that cannot disappear. No intention is required for this filtering to operate. It is an automatic consequence of interaction. The universe does not ask what a structure is for. It only asks whether it lasts. From the earliest moments onward, reality has been engaged in a continuous process of sorting, not sorting by value or significance, but by endurance. Wherever energy, matter, and geometry interact, there are many possible configurations. Most of them are fleeting. A small subset persists. That subset becomes what we call structure. Consider something as simple as a clump of matter. In a perfectly uniform universe, no structure would form. Everything would expand evenly, and no region would ever stand out. But the real universe was not perfectly uniform. Tiny fluctuations existed from the beginning, minuscule differences in density, temperature, and motion. Those differences mattered, not because they were meaningful, but because gravity responds to imbalance. Where there was slightly more matter, gravity pulled slightly harder. Where gravity pulled slightly harder, more matter accumulated. This feedback loop did not care what it produced. It only responded to gradients. Over time, those gradients sharpened and structure emerged, not because it was intended, because it was allowed. This pattern repeats at every scale. Atoms form because certain electron configurations are energetically favorable. Molecules assemble because shared electron states lower energy further. Crystals grow because repeating lattices distribute stress efficiently. Stars ignite because gravitational compression raises temperatures high enough for nuclear fusion. Planets coalesce because angular momentum and dissipation favor flattened disks. In none of these cases does the system know what it is becoming. Each step follows from constraint. This is why structure in the universe often appears layered. New forms do not replace old ones. They sit on top of them. Atoms do not erase particles. Molecules do not erase atoms. Stars do not erase chemistry. Each layer persists because it remains stable under the conditions created by the previous layer. Meaning plays no role in this stacking. We are so accustomed to intentional structure that we struggle to accept this. When we see spiral galaxies, we speak of elegance. When we see crystal lattices, we speak of symmetry. When we see planetary systems, we speak of balance. These words describe our response, not the universe's motivation. From the universe's perspective, these are simply long-lived arrangements. They are not special because they are beautiful. They are beautiful because they are special. Special in the narrow sense that they resist dissolution longer than nearby alternatives. This reframing strips structure of narrative but not of richness. In fact, it makes structure more remarkable, not less. The fact that complexity can arise without foresight, that coherence can accumulate without guidance, is more surprising than the idea that it was planned. Structure without meaning is not chaos, it is selective persistence. Every environment imposes constraints, temperature limits which bonds can survive, pressure limits which phases are stable, radiation limits which configurations endure, geometry limits how forces propagate. Within those limits, some arrangements last longer than others. That is enough to sculpt order. Importantly, this process does not aim for optimality. The universe does not seek the best structure. It accepts whatever works well enough. Many configurations coexist. Many fail. Many persist only briefly. Over time, the landscape fills with whatever can survive the prevailing conditions. This is why cosmic structure is messy. Galaxies collide. Stars form in bursts and then die. Planetary systems are unstable over long timescales. Nothing about this resembles a finished product. There is no final form. There is only ongoing sorting. And yet from within that sorting, patterns emerge. Filaments span millions of light years. Voids open between them. Disks flatten. Spirals rotate. Chemical pathways repeat. These patterns are not imposed. They are discovered by matter as it explores the space of what is allowed. This idea can feel uncomfortable because it removes purpose from the picture. We often want structure to mean something. We want it to point beyond itself. But in a universe without observers, structure points nowhere. It simply exists. And this is where a subtle but crucial distinction arises. Meaninglessness does not imply insignificance. Something can lack meaning and still be consequential. A star does not need meaning to fuse hydrogen. A galaxy does not need purpose to shape gravitational orbits. These processes have effects regardless of interpretation. The universe is not nihilistic. It is indifferent. Indifference is not emptiness. It is freedom from obligation. The universe is free to explore configurations without justification. It does not have to explain itself. It does not have to care whether its structures will someday be admired, studied, or understood. They form anyway. This perspective also clarifies a common confusion between order and intention. Humans often assume that order implies a planner because in our experience, complex order usually does. But that is a parochial bias. We are used to living inside systems shaped by minds. The universe is not one of those systems. It is a system that occasionally produces minds. And those minds, once they appear, retroactively project meaning onto structures that predate them by billions of years. There is nothing wrong with that projection. Meaning is real, but it is local. It belongs to observers, not to the processes that made them possible. The mistake is to reverse the direction of causation and assume that meaning was present from the start. It was not. Structure came first. Meaning came later. And that ordering matters because it tells us something profound about our place in the universe. We are not the reason structure exists. We are one of the many structures that exist because the universe is good at producing persistent arrangements. In the next section, we will look at one of the most striking examples of this blind creativity, the formation of stars, galaxies, and chemistry, systems that built complexity for billions of years without witnesses, intention, or awareness, and in doing so, quietly prepared the conditions for everything that followed. Section 4. Stars, Galaxies, and Chemistry. Proceeding blindly. Once structure begins to form, it does not stop at simple arrangements. Left alone under the right conditions, the universe builds upward. Not because it wants to, but because persistence favors the accumulation of complexity when energy can be dissipated and structure can endure. Nowhere is this more evident than in the long, patient evolution of stars, galaxies, and chemistry. These systems feel purposeful when we look at them from the inside. Stars power life. Galaxies host worlds. Chemistry enables biology. It is tempting to see these as steps in a story leading toward us. But from the universe's perspective, there is no story arc. There is only continuation. The first stars formed hundreds of millions of years after the beginning, long after atoms had already existed in darkness. Gravity slowly gathered hydrogen and helium into denser regions. As clouds collapsed, their interiors heated. When temperatures became high enough, nuclear fusion ignited. This ignition was not a milestone. It was a threshold. Fusion turns mass into energy. That energy pushes outward, resisting further collapse. When gravitational compression and fusion pressure balance, a star stabilizes. If the balance shifts, the star changes or dies. This is not a decision. It is feedback. Stars are not born to shine. They shine because shining slows collapse. That single fact explains an enormous amount of cosmic structure. Radiation is a way to get rid of excess energy. Systems that can radiate efficiently can persist longer. Systems that cannot tend to destabilize and transform. Stars exist because they are good at shedding energy. Galaxies form for similar reasons. Rotating clouds flatten into disks because angular momentum must be conserved while energy can be dissipated. Material settles into orbits because chaotic motion is energetically expensive. Over time, ordered rotation outlasts disorder. Again, nothing is trying to create elegance. Disks persist because they are stable. Spiral arms are not structures in the material sense. They are patterns in motion, density waves moving through rotating matter. They exist because of how gravity and rotation interact, not because they are useful or meaningful. Galaxies do not care what shape they take. They take whatever shape survives. Within stars, chemistry begins to deepen. The first generations of stars fused hydrogen into helium, helium into carbon, and onward into heavier elements. These elements were not created for complexity. They were created because nuclear reactions follow paths of increasing binding energy under extreme conditions. When massive stars exhausted their fuel, they collapsed and exploded, scattering heavy elements into space. This process enriched the surrounding medium. Later stars formed from that enriched material. Planets condensed from disks containing carbon, oxygen, nitrogen, iron, and countless other elements. Chemistry expanded not because life needed it, but because the universe kept reusing its own leftovers. This recycling is one of the universe's most powerful blind mechanisms. Nothing is wasted in the moral sense, but everything is repurposed in the physical sense. Matter that once formed the core of a star may later become part of a planet, a molecule, or a cell, not because the universe planned it that way, but because material follows available pathways. Chemical complexity grows because certain bonds are robust under a wide range of conditions. Carbon, in particular, forms stable, versatile structures, not because it is special in a narrative sense, but because its electron configuration allows many arrangements that persist. Blind chemistry is opportunistic. It explores what is allowed and keeps what lasts. Over billions of years, molecular clouds produced increasingly complex compounds. Simple molecules combined into larger ones. Reaction networks formed. None of this required life. None of it required awareness. It required only energy flows, gradients, and time. The universe had time. One of the most misleading intuitions we carry is that complexity must be fast or intentional. In reality, complexity is often slow and accidental. Given enough time, even rare pathways are explored. Given enough volume, even unlikely configurations appear. Persistence does the rest. Stars live for millions to billions of years. Galaxies evolve over billions. Chemistry operates continuously in clouds, disks, and planetary surfaces. These timescales are so vast that processes which seem improbable on human scales become inevitable. And still, no one is watching. No one observes fusion reactions in stellar cores. No one monitors the assembly of spiral arms. No one interprets molecular collisions in interstellar space. These processes unfold in complete absence of awareness. This is crucial. Physical interaction does not require observation to occur. Reactions do not wait for witnesses. Fields do not pause for measurement. The universe does not hold itself in suspense. It acts. From our vantage point, it can feel as though observation plays a special role. We measure stars, we analyze spectra, we map galaxies, but these acts of measurement do not activate reality. They sample it. They extract information from processes that were already fully underway. The universe is not performing for us. We arrive late, read the traces, and mistake our reading for participation. Stars burned for billions of years before the first eyes ever opened. Galaxies collided long before there were minds to be astonished. Chemistry ran wild in dark clouds, with no biochemist to name reactions or classify outcomes. And yet these blind processes built the scaffolding of everything that would follow. This is where the narrative often shifts toward teleology, toward the idea that complexity was leading somewhere. But that is a retrospective illusion. The universe did not aim for life. Life emerged because the universe happened to produce environments where certain chemical systems could persist and replicate. Blind does not mean barren. Blind processes can generate abundance, diversity, and depth, provided they are given time and room to operate. The universe had both. By the time life finally appeared, the cosmos was already old. It had already been structured, enriched, and filtered by billions of years of persistence. Life did not invent complexity, it inherited it. In the next section, we will sharpen this idea by examining how selection operates without intention, how outcomes are filtered, not chosen, and how the universe performs something that looks uncannily like decision-making without ever deciding anything at all. Section 5. Selection without intention. When people hear the word selection, they almost always imagine a selector. They imagine a mind evaluating options, weighing outcomes, and choosing what should continue and what should end. In everyday life, selection is inseparable from intention. We select tools, routes, words, and actions because we want something the universe does not want. And yet, selection happens everywhere. This is one of the most counterintuitive but essential ideas in a universe without observers. Outcomes can be filtered without being chosen. Persistence itself performs the work that intention seems to perform in human systems. Nothing needs to decide what survives. Survival emerges automatically from interaction with constraints. At every scale, the universe presents systems with conditions. Temperature, pressure, radiation, geometry, and available energy define what is possible in a given region. Within that space of possibilities, many configurations are tried. Most do not last. The ones that do last accumulate. That accumulation creates the illusion of choice. Consider something as simple as a rock on a hillside. Gravity pulls it downward. Friction resists motion. If the slope is gentle and the rock is stable, it stays. If the slope is steep and the rock is unstable, it rolls until it reaches a configuration where forces balance. No one selects the final resting place. The rock stops where motion can no longer continue. That is selection without intention. Now extend this logic to the universe as a whole. Atomic configurations that radiate excess energy settle into stable states. Molecular arrangements that break easily disappear. Stellar systems that cannot balance pressure and gravity collapse or explode. Planetary orbits that are unstable decay. None of these systems evaluate alternatives. They simply respond. This kind of selection is ruthless but not cruel. It has no preferences. It does not optimize for elegance or complexity. It accepts whatever configuration can endure under the prevailing conditions. This is why the universe is filled with inefficiency. Most matter never becomes part of life. Most stars never host habitable planets. Most chemical reactions lead nowhere interesting, but what survives does not survive because it was favored. It survives because nothing destroyed it yet. This distinction matters deeply. In intentional systems, selection aims toward a goal. In blind systems, selection is a byproduct of failure. Everything that cannot persist is removed. What remains is simply what remains. This is not a process that happens once. It happens continuously. Every interaction filters possibilities. Every collision eliminates some outcomes and allows others. Over time, this filtering compounds. Layers of persistence build on top of earlier layers, not because they are better, but because they are compatible with what already exists. This is why complexity often appears path-dependent. The universe does not explore all possibilities evenly. It explores what is reachable from what already persists. Once a configuration dominates a region, it shapes the future by constraining what can form next. No foresight is involved. The universe does not plan its next move. It does not anticipate future environments. It simply reacts locally, moment by moment, and lets time do the sorting. This is the same mechanism that later appears in biological evolution, but it is not unique to life. Long before genes, reproduction, or organisms existed, the universe was already filtering outcomes. Nuclear reactions select certain isotopes over others. Cooling gas selects certain molecular bonds. Rotating disks select certain orbital configurations. Radiation fields select which structures can survive exposure. Life inherits this filtering. It does not invent it. This point is often missed because biological evolution is the first place where selection becomes visible at human scales. We see organisms competing, adapting, and diversifying. It feels active. It feels purposeful. But the underlying mechanism is the same one that shaped stars and galaxies: persistence under constraint. What makes biological selection feel different is that replication accelerates the process. But replication is not intention. It is a physical mechanism that amplifies persistence. Systems that copy themselves spread. Systems that fail to copy disappear. Again, no one chooses. The universe does not care which chemical pathways lead to life. It does not favor intelligence. It does not protect awareness. Life persists where it can and disappears where it cannot. Most of the universe remains lifeless not because life was rejected, but because conditions did not support it. Selection without intention is indifferent to outcomes. This indifference is often mistaken for hostility or meaninglessness. It is neither. It is simply the absence of preference. The universe does not owe persistence to anything. It does not guarantee continuation. It does not promise progress. What persists does so provisionally. Everything that exists is living on borrowed time. This may sound bleak, but it carries an unexpected clarity. If persistence is not granted by meaning, then meaning is not a prerequisite for existence. Things can exist, endure, and interact without being justified. They do not need a reason beyond compatibility with their environment. This frees us from the idea that the universe must make sense in human terms in order to be real. It also prepares us for a deeper insight. Selection without intention produces something that looks uncannily like memory. Structures that persist encode information about the conditions they survived. The universe remembers not because it tries to, but because persistence leaves traces. That is where we are headed next. In the following section, we will explore how memory can exist without minds, how physical systems record their past interactions simply by continuing to exist in a particular state, and how the universe carries its history forward without ever reflecting on it. Section 6. Memory without minds. When we hear the word memory, we instinctively think of minds. We imagine recollection, awareness of the past, or the conscious act of remembering. Memory, in everyday language, is something experienced. It involves recognition, comparison, and meaning. Without a mind, memory seems impossible. But physics tells a different story. Long before there were minds capable of recall, the universe was already recording its own history, not symbolically, not narratively, physically. Memory does not require awareness. it requires persistence. In a universe without observers, memory is simply the fact that the present state of a system depends on its past interactions. Every physical system carries traces of what has happened to it. A rock bears marks of erosion. A star's composition reflects generations of prior fusion. A planet's surface records impacts, flows, and tectonic shifts. None of these systems remember in the human sense, and yet they encode information about their past. That encoding is memory. At its most fundamental level, memory is correlation across time. When an interaction leaves a lasting change, the system has recorded something. The universe is filled with such records, layered on top of one another, accumulated blindly. Particles scatter and their trajectories change. Fields fluctuate and correlations propagate. Matter collapses and geometry warps. Each of these processes alters the future behavior of the system. The system does not reset. It carries forward the consequences of what has already occurred. Nothing needs to notice. This is why the early universe could leave legible traces billions of years later. The cosmic microwave background is not a message sent to future observers. It is a frozen imprint of conditions at a particular time. Its tiny temperature variations encode information about density fluctuations that existed when the universe was less than 1 million years old. No one was there to store that information. It was stored automatically. Similarly, elemental abundances throughout the universe are not chosen. They are the residual outcome of nuclear processes that occurred under specific conditions. The ratio of hydrogen to helium, the presence of heavier elements, the distribution of isotopes, all of these are records of what reactions were possible and which ones persisted. Memory without minds is everywhere once you know how to look. A crystal remembers the conditions under which it grew through defects in its lattice. A fossil records a biological structure long after the organism has vanished. A gravitational wave carries information about a violent event across vast distances, even if it passes through empty space for eons before interacting with a detector. In each case, memory is not stored because someone intends to remember. It is stored because interaction alters state. This kind of memory is indifferent to interpretation. It does not care whether it will ever be read. Most of it never is. The universe is saturated with records that will never be decoded by any mind. That does not make them less real. In fact, it makes them more fundamental. Mental memory is a special case layered on top of physical memory. Brains remember by exploiting physical persistence, stable synaptic changes, chemical gradients, and electrical patterns that outlast the moments that created them. Conscious recall is built from the same principle that allows rocks to retain scars and stars to retain composition. Nothing magical is added. What changes is locality and accessibility. This reframing dissolves a common confusion about observation and reality. We often think that without observers there would be no records, that events would leave no trace unless witnessed. Physics says the opposite. Witnessing is not what creates records. Interaction is. When two particles collide, the universe remembers the collision in their altered trajectories. When a star explodes, the universe remembers in the distribution of debris. When light passes through space, it carries imprints of what it encountered along the way. No awareness is required. This has profound implications for how we think about measurement. Measurement does not create memory, it extracts it. Instruments do not cause systems to record information. They intercept records that already exist in physical form. The universe does not wait for measurement to decide what happened. It already happened. This is where many discussions of quantum mechanics become confused. Language borrowed from psychology, words like observation and measurement, can mislead us into thinking that minds play a fundamental role. But in practice, measurement is just another physical interaction, one that couples a system to a macroscopic environment where outcomes become durable. The durability is the key. Memory requires robustness. A fleeting interaction that leaves no lasting trace is forgotten by the universe itself. An interaction that produces a stable change becomes part of history. Over time, layers of such durable changes accumulate, forming a ledger of what has occurred. This ledger is not centralized. It is distributed across matter, energy, and geometry. It has no index, no summary, no narrative thread. But it is consistent. The universe does not contradict its own records. What has happened constrains what can happen next. This constraint is the true function of memory. Memory narrows the space of possibilities. It does not replay the past. It shapes the future. A planet that has cooled cannot behave like one that is molten. A star that has exhausted its fuel cannot shine like one that is young. The universe moves forward, carrying the weight of what it has already done, and still no one is there to reflect on it. This brings us to a subtle but important realization. Meaningless memory is not pointless memory. Records matter even when no one reads them. They matter because they influence future dynamics. They determine what is possible next. The universe remembers in order to persist, not in order to understand. Only much later does something new appear, systems that can read those records, compare them, and construct internal models. Observers do not create memory, they consume it. In the next section, we will confront one of the most persistent confusions in modern physics, the idea that physical interaction becomes real only when it is measured. We will disentangle interaction from observation and examine why the universe does not require witnesses to function, even at the quantum level. Section 7. Physical interaction versus measurement. Few ideas have caused more confusion about observers than the concept of measurement. In everyday language, to measure something is to look at it, to observe it, to check what it is doing. When this language is imported into physics, especially quantum physics, it quietly carries the implication that observation itself plays a fundamental role in making reality real. This implication is deeply misleading. The universe does not distinguish between interactions that are measured and interactions that are not. It distinguishes only between interactions that leave durable traces and those that do not. Everything else is human bookkeeping. To understand a universe without observers, we must strip measurement down to its physical core. Measurement is not awareness. It is not attention. It is not consciousness. Measurement is a physical interaction that couples a system to a larger environment in a way that stabilizes certain outcomes, nothing more. When two particles collide, that is an interaction. When a photon scatters off an atom, that is an interaction. When a detector registers a signal, that is an interaction. In all three cases, the universe responds in the same way. States change, correlations form, and future possibilities are constrained. No mind is required. The reason measurement feels special is not because it activates reality, but because it amplifies microscopic events into macroscopic records. A detector does not observe a particle in a privileged sense. It entangles the particle with an environment large enough that the outcome becomes effectively irreversible. Irreversibility is the key. The universe is constantly interacting with itself. Most interactions are small and transient. They leave traces that quickly wash out or become inaccessible. But when an interaction couples a system to many degrees of freedom, a measuring device, an environment, a thermal bath, the trace becomes robust. That robustness is what we call a measurement outcome. From the universe's point of view, there is no categorical difference between a particle scattering off a dust grain in deep space and a particle scattering inside a laboratory detector. Both are interactions. Both leave records. One happens to be useful to humans. This distinction matters because it dissolves the idea that reality is somehow incomplete until measured. Nothing is suspended. Nothing is undecided in a mystical sense. Systems evolve continuously through interaction, regardless of whether those interactions are noticed. Quantum mechanics does not change this. Quantum systems are often described as existing in superpositions until observed, but what observation actually means, in physical terms, is coupling to an environment that destroys coherence between alternatives. This process, decoherence, happens constantly, everywhere, without observers. A photon interacting with interstellar dust decoheres. A molecule interacting with background radiation decoheres. A quantum state interacting with its surroundings loses the ability to exhibit interference long before any mind is involved. The universe is not delicately balancing possibilities until we look. It is relentlessly interacting. The confusion arises because we tend to conflate two different questions. One is a physical question. How do systems evolve and leave records? The other is an epistemic question. What can we know about those systems? Measurement answers the second question for us. It does not resolve the first question for the universe. The universe does not need to know. This distinction becomes especially clear when we consider deep time. Events that occurred billions of years ago were not measured in the human sense, and yet they happened. Their consequences propagated forward. Their traces still shape the present. Supernovae exploded without witnesses. Black holes merged without detectors. Particles decayed without records being archived. And yet those events are part of the universe's history. Measurement does not grant existence. It grants access. When we build instruments, we are not causing events to occur. We are positioning ourselves to intercept interactions that would have happened anyway. Our detectors are just another part of the environment, one designed to preserve certain traces in forms we can read. This reframing removes the mystique from observation without diminishing the strangeness of quantum physics. Quantum behavior remains non-intuitive, probabilistic, and deeply constrained by uncertainty, but it does not require consciousness to function. The universe does not care whether a wave function is written on a chalkboard. It cares only about interaction. This has an important consequence for how we think about observers. Observers are not fundamental to physics. They are emergent systems that exploit physical interactions to build internal models. They are consumers of measurement, not producers of reality. The language of collapse often obscures this point. Collapse is not a physical event triggered by awareness. It is a shorthand for the transition from reversible, coherent evolution to effectively irreversible classical records due to environmental coupling. That transition happens constantly, everywhere, whether or not anyone is watching. This is why a universe without observers is not a paradox. It is the default case. Observation is an addition, not a requirement. The universe ran for billions of years without a single measurement in the human sense, and it ran just fine. Only after complexity crossed certain thresholds did systems appear that could stabilize records internally, compare them, and form representations. Those systems became observers, which leads us to the next step in the story. If the universe does not require observers, and if meaning and measurement are late additions, then meaning itself must be local, provisional, and fragile. It cannot be written into the fabric of reality. It must arise where conditions allow. In the next section, we will examine why meaning is always temporary and local, why it cannot persist at cosmic scales, and why that fact does not diminish it. Section 8. Why meaning is local and temporary. Meaning feels immense from the inside. When we experience meaning in a thought, a memory, a relationship, or a discovery, it can feel absolute, as if it reaches beyond us and anchors itself in the universe itself. This feeling is powerful and it is real, but it is also misleading when projected onto cosmic scales. In a universe without observers, meaning has no place to live. This is not because the universe is hostile to meaning, but because meaning requires conditions that are rare, fragile, and local. Meaning is not a property of matter or energy. It is a property of organized systems that can compare, value, and interpret. And those systems arrive very late. To see why meaning cannot be fundamental, we need to understand what meaning actually is in physical terms. Meaning is not information by itself. Information exists everywhere. Particles carry information about their states. Fields encode correlations. Physical memory records past interactions. Meaning arises only when information is evaluated relative to goals, constraints, or internal models. That evaluation requires a system that can care. Stars do not care what they are made of. Galaxies do not care how they rotate. Atoms do not care which bonds they form. These systems persist or fail without preference. They have no stake in outcomes. Meaning enters the picture only when a system's continued existence depends on distinguishing one state from another. Life introduces this distinction. A living system must maintain itself far from equilibrium. It must regulate energy flows, repair damage, and reproduce. To do this, it must treat some information as relevant and other information as irrelevant. That relevance is the seed of meaning. But even here, meaning is not universal. It is contextual. What matters to one organism may be meaningless to another. What matters in one environment may be irrelevant in another. Meaning is not only local in space, it is local in circumstance. This locality is not a flaw, it is a feature. Meaning is an adaptive overlay on a universe that does not provide it by default. It allows certain systems to persist longer by responding selectively to their environment. It is a tool, not a foundation. This explains why meaning is temporary. Systems that generate meaning are themselves subject to selection, decay, and extinction. When a system disappears, its meanings disappear with it. The universe does not preserve meaning in the way it preserves mass energy or momentum. Meaning does not leave durable traces unless it is encoded into physical structures, and even then, only as patterns, not as significance. A book can persist, but its meaning does not exist without a reader. A signal can travel, but its significance depends on a receiver. A memory can be stored, but its importance vanishes when the system that values it is gone. The universe remembers events. It does not remember what they meant. This distinction is subtle but crucial. Physical memory preserves correlations. Meaning requires interpretation of those correlations relative to a perspective. Without that perspective, meaning evaporates. This is why cosmic processes do not accumulate meaning over time. The universe does not get wiser. It does not learn lessons. It does not converge on truth or purpose. It simply accumulates structure and records interactions. Observers, when they appear, temporarily carve meaning out of that structure. This carving is real. It matters locally, but it is not universal. There is a temptation to resist this conclusion, to argue that meaning must exist independently of observers. But physics offers no mechanism for that. Meaning is not conserved. It does not propagate like energy. It does not constrain future dynamics, unless it is translated into action by a system that cares. And those systems are ephemeral. Civilizations rise and fall. Species evolve and vanish. Even stars and galaxies are temporary. The timescales differ, but nothing persists indefinitely. This does not diminish meaning. It places it where it belongs. Meaning is precious precisely because it is not guaranteed. It is a rare phenomenon in a universe that does not require it. It appears briefly, does its work, and disappears, leaving behind only the physical consequences of the actions it motivated. This perspective also clarifies why the universe does not appear to reward meaning. There is no cosmic feedback loop that amplifies significance. Meaningful acts do not alter fundamental laws. They alter local trajectories, and that is enough. The mistake is to expect the universe to care in the same way we do. Care is a biological achievement, not a cosmic one. It emerges under specific conditions and fades when those conditions disappear. Which brings us to a natural transition. If meaning is local and temporary, then observers, systems capable of generating meaning, must also be late arrivals. They cannot be foundational. They must emerge from blind processes that preceded them by billions of years. In the next section, we will examine how observers arise at all, how a universe that does not need to be seen nevertheless produces systems that see, reflect, and ask questions. Section 9. How observers emerge late. If the universe does not require observers, a deeper question follows naturally. Why are there any observers at all? Why does a universe that functions perfectly well without awareness nevertheless produce systems that perceive, remember, and reflect? And why do those systems appear only after billions of years of blind evolution? The answer is not that observers were planned. The answer is that observers are an emergent side effect of persistence under constraint. By the time the first observers appeared, the universe was already old. Stars had formed and died. Galaxies had evolved. Chemistry had diversified. Environments existed where energy flowed steadily and gradients could be exploited. None of this was arranged in anticipation of life. It simply happened to create niches where certain physical systems could last longer by responding selectively to their surroundings. Observation begins not with curiosity, but with survival. The earliest precursors to observers were not thinkers, they were regulators. Systems that could sense aspects of their environment and respond in ways that preserved their internal organization. These systems did not understand what they sensed, they reacted. This distinction matters. Sensing is not observing. Reaction is not awareness. Early life did not watch the universe, it was embedded in it, buffeted by forces it could not conceptualize, shaped by conditions it did not comprehend. What made these systems different from non-living matter was not intention, but feedback. They formed closed loops where information about the environment influenced internal processes, which in turn affected future interactions. These loops allowed certain configurations to persist longer than others. Over time, these feedback systems became more elaborate. Memory extended beyond immediate reactions. Internal states began to represent past conditions. Anticipation, in a crude, statistical sense, emerged. Still, no meaning in the human sense existed. Meaning arises only when representations become decoupled enough from immediate action to be compared, evaluated, and shared. This requires layers of abstraction, redundancy, and stability. It requires energy budgets large enough to support complexity without immediate payoff. That took time. For most of Earth's history, life existed without anything resembling an observer. Single-celled organisms dominated. They sensed and reacted, but they did not reflect. They left no records of experience because there was no experience to record. Only much later did nervous systems appear. Only later still did brains capable of modeling the world, predicting outcomes, and forming internal narratives evolve. Observation, as we understand it, is the product of this long accumulation, and even now it is rare. The universe is not filled with observers. It is filled with stars, gas, dust, radiation, and dark matter. Observers occupy a tiny fraction of space, a tiny fraction of time, and a tiny fraction of possible configurations. This rarity is not surprising. Observers are expensive. They require continuous energy flow, fine-tuned conditions, and robust error correction. They are fragile. Small disruptions can end them. Most environments cannot support them for long. From the universe's perspective, observers are just another transient structure. They are not privileged. They are not central. They are not required. They emerge where conditions allow and disappear when conditions change. What makes observers distinctive is not their necessity, but their capacity to model. Observers build internal representations of the world. They compress information. They infer patterns. They assign meaning. These activities are not demanded by physics. They are strategies for persistence. A system that can anticipate danger, locate resources, and coordinate action can persist longer than one that cannot. Over evolutionary timescales, this advantage compounds. Eventually, representation becomes reflection. At that point, the universe produces something new, a system that can ask what the universe is doing. This is a remarkable turn, but it is not a reversal. The universe does not suddenly become dependent on observers. Observers become dependent on the universe. They ride on top of blind processes, extracting local meaning from structures that were never meant to carry it. This helps explain why observation feels central from the inside. For an observer, everything that matters passes through perception. Awareness is the gateway to experience. It feels fundamental because it is the foundation of our internal world. But internally fundamental is not cosmically fundamental. Observers mistake their vantage point for the center of reality because it is the center of their reality. Physics reminds us that this center is local, temporary, and contingent, and that realization leads to one final question. If observers emerge late, and if meaning is local, what happens when observers disappear? What, if anything, persists after minds are gone? In the final section, we will step back and consider a universe that outlives observation, a universe that continues without memory of meaning, carrying forward only what was physically preserved. Section 10. What persists after observers disappear? A universe that continues. When we imagine the end of observers, our imagination tends to collapse inward. We picture silence as absence, emptiness as loss. A universe without minds can feel like a universe that has somehow failed, as if observation were the point, and without it, nothing remains worth continuing. But this is another projection. The universe does not experience the disappearance of observers as an ending. It experiences it as a transition, one more change among many, governed by the same rules that allowed observers to arise in the first place. What persists after observers disappear is exactly what persisted before they appeared. The universe continues to do what it has always done. Energy redistributes, structures evolve, interactions occur, and records accumulate. Stars continue to burn or fade. Galaxies continue to orbit and collide. Chemistry continues wherever conditions allow. Radiation continues to travel. Space-time continues to curve in response to mass and energy. Nothing about this requires awareness. The disappearance of observers does not erase physical memory. It does not undo structure. It does not rewind history. All the traces left by observers, their constructions, emissions, alterations of environments, become part of the universe's ongoing record. Cities decay, satellites drift, artifacts erode, signals propagate outward until they dissipate into noise or are absorbed. These remnants persist for a time, then transform, then disappear, just like everything else. The universe does not preserve intention. It preserves consequence. This is the final asymmetry that matters. Meaning vanishes when the systems that generate it vanish, but effects remain as long as they are physically encoded. A civilization's values disappear when the civilization ends, but the physical changes it caused, altered atmospheres, redistributed materials, modified orbits, emitted radiation, continue to shape the future. In this sense, observers do leave footprints, not because they were observed, but because they interacted. Those footprints are not special in kind. They differ only in degree. Stars alter their surroundings. Supernovae reshape galaxies. Black holes reorganize space-time. Observers are just another source of change, localized, temporary, and ultimately absorbed back into the larger flow. This perspective removes a quiet anxiety that often accompanies discussions about meaning and mortality. If meaning were required for the universe to function, then its disappearance would be catastrophic. But meaning is not required. It is an overlay, not a pillar. The universe is robust against the loss of interpretation. It has always been. Long after the last observer fades, the universe will still carry a history. That history will not be experienced. It will not be remembered. It will not be understood. But it will exist, encoded in distributions, correlations, and constraints, just as it always has. This is not nihilism. It is continuity. The universe does not mourn the absence of witnesses because mourning is not a physical process. What it does, instead, is continue to unfold according to the same principles that governed its earliest moments. Persistence under constraint. From this vantage point, observers are neither central nor insignificant. They are transient structures that briefly extract meaning from a universe that does not supply it. They matter locally, intensely, and briefly, and then they are gone. What remains is not emptiness, but process. This realization completes the arc of this pillar. We began by asking whether a universe without observers could even be possible. We end by recognizing that such a universe is not only possible, it is the default state. Observers are not the reason the universe exists. They are one of the things it does, and that understanding does not diminish us. It situates us. In the closing synthesis, we will step back and connect this pillar to the larger framework, not to restore observers to the center, but to show how a universe that does not need to be seen can nevertheless give rise to systems that see, reflect, and briefly care. 1. As we step back from this long walk, something important should now feel settled. The universe does not lean toward us, it does not wait for us, and it does not require us. And yet, we are here. That is not a contradiction, it is the result. What this pillar has tried to show is not that observers are unimportant, but that they are late. Meaning is not foundational. Awareness is not structural. Observation is not a prerequisite for reality to unfold. The universe operated for billions of years without witnesses, and it will continue long after the last one is gone. What persists is not meaning, but consequence. Matter remembers through state. Energy remembers through distribution. Geometry remembers through curvature. The universe keeps its own ledger, written not in symbols or stories, but in constraints and correlations. That ledger does not care whether it is read. It does not preserve significance. It preserves what happened. Observers enter this picture only when complexity crosses a threshold where internal models become useful, not for truth, but for survival. Awareness emerges because it helps certain systems persist longer under local conditions. Meaning appears because distinguishing one outcome from another matters to those systems. Meaning is not false, but it is local. This distinction changes how we understand ourselves. We are not the point of the universe. We are not its audience. We are not its judges. We are temporary structures that briefly learn how to read a world that was already written. That reading is extraordinary. For a short window of cosmic time, the universe produces systems capable of reconstructing its past, modeling its future, and reflecting on their own impermanence. That capacity is not trivial. It is not dismissible. It is not small, but it is not central. And that is not an insult. It is a clarification. When we remove observers from the center, something subtle happens. The universe becomes calmer, less theatrical, and more patient. Structure no longer needs justification. Persistence no longer needs purpose. Reality no longer waits for interpretation. It simply unfolds. This perspective does not drain meaning from our lives. It protects it. Meaning becomes something we generate, not something we demand the universe provide. It becomes a responsibility rather than an entitlement. We care because we can. We interpret because we are built to. We observe because we emerged from processes that did not need observation. That makes awareness precious, not privileged. If this pillar leaves you with anything, let it be this quiet inversion. The universe does not exist to be known. Knowledge exists because the universe persists long enough to produce knowers. We are not the reason reality happens. We are one of the things that happen. And when we are gone, the universe will not notice our absence, but it will carry forward the traces of what we did, just as it carries the traces of stars, galaxies, and ancient light. That is not erasure. It is continuity. In the larger arc of this series, this pillar matters because it removes a silent bias. It clears space for understanding persistence, structure, and information as physical processes first, not philosophical ones. Observers return later, not as architects, but as participants, late, local, temporary, and still capable of wonder. That is enough. Before we close, I want to thank you for taking the time to walk through this with me. These are not fast ideas, and this is not a fast universe. If you stayed with it, that patience matters. My name is Charles Carroll, and this channel is an ongoing attempt to explore how structure, persistence, and understanding arise without assuming we are at the center of the story. If this way of looking at the universe resonated with you, you're welcome to continue along in the next pillar. And if it didn't, that's fine too. The universe does not require agreement. It only requires time. Thank you for listening.